Today I'm going to be chatting with Ilias from Ilias in the Cloud about Lambda and although it's super easy to get started with Lambda, there are quite a few topics that you need to learn if you really want to be able to master Lambda. We're going to start by just having a quick look at the original post that got me and Ilias talking about this, and then we're going to go through and kind of discuss each of the points, why we think they're important, and basically how we think we can learn it. But for any of the complete coding followers that doesn't know Ilias, do you want to introduce yourself?
Of course. Thanks, Sam. Thanks for inviting me. My name is Ilias. I run a YouTube channel called Ilias in the Cloud. I'm a senior solutions architect. I've been working in the cloud for the past decade, well, basically since the cloud has become a little bit of a mainstream. And we've been following each other. I love the content that you put out there. I've seen your post on LinkedIn and I was like, this would be a great opportunity to, just try to put some good content for both our followers, but also for people who are interested in learning more about Lambda function. Because to your point, it sounds simple. And AWS and all these cloud providers, they want you to think of it as simple. You don't think about anything. You just come, focus on your business logic, and we will take care of everything else. That's, at least that's the promise. But I'm sure as we will discuss during this video, there are a couple of things here and there that you should be aware of in order to gain, to take advantage of this engine that is Lambda function and serverless functions.
Yeah, that's a really good summary, I think. And yeah, looking forward to seeing your viewpoint on some of these. So let's start by just getting up the original post. So as you can see here, just talking about, as we've said, how it's easy to get started, but there are some more advanced topics. Some of those topics include how Lambda scales and the concurrency models. You've got the dreaded cold starts that everyone is really scared of, but once you understand them, they're not too bad. Things about environment variables, what you should and shouldn't put in your Lambda environment variables. Lambda memory to CPU relationship and how that can affect your performance. Lambda layers, deployment package optimization, so that's another performance thing. Then provisioned or reserved capacity, global variables, reuse of database connections and other things outside of the main handler. Versioning, which is going to be an interesting one, and then x86 versus ARM and how that can affect things. So do you want to start at the top and go with how Lambda scales and concurrency? And do you want to kick us off with why you think it is or isn't an important thing to learn, and any tips you have for people who are interested in that?
Of course, yeah. I mean, one of the biggest promises of Lambda and why majority use Lambda is for its scalability features. The promise is, you know what? You don't have to pre-provision. You don't have to choose even a size, specific size, T3 medium, 4X, whatever. No. You just bring us your code and then we will figure out the best way to put it out there and then we will scale it for you. This is a great promise. This is awesome. This means that whether you're a startup, whether you're someone who's building a simple, I would say, application in your house during the weekend, or whether you're an established company, you offload. And this is the term that I like to use. Is basically you offload a lot of that ops management to the cloud. You don't have to think about it. You just focus on but as the saying goes, with big power comes responsibility. What the Spider-Man says?
With great power comes great responsibility.
With great power comes great responsibility. Yes, you can push the Lambda. You can just put your code and push it there and then wait and rely on the Lambda to scale it for you. But at some point, it requires you to configure a couple of parameters here and there in order to keep taking advantage of that Lambda function. I mean, I think the cloud, as pretty much everything else, it works for you until it doesn't. So like it works, it takes care for everything for you until you reach a point where you're talking about 10 times your current traffic or 100 times your current throughput. And then you have to, I would say, just be a little bit more active, a little bit more involved, right? And that's where we start talking about concurrency and we start talking about provisioned concurrency. And so pretty much the way Lambda works is dependent on the requests it receives, right? So your Lambda is running, it's your compute layer. So for every request that your workload receives, Lambda will spin up a new container, a new instance. I think that's the more technical, that's a better word, a new instance to run your code. And so this instance, think of it as a small, tiny virtual machine based on Firecracker. So it is still like a super tiny container, but the cloud is not infinite, even though we think that the cloud is infinite and we like to think that the cloud is infinite, it's not. So imagine your traffic just went up by 100%, or imagine, 100 times, or imagine you're under DDoS attack. So you don't want all these requests consuming all your Lambda resources left and right and center and spinning off all these things and you paying for them. So that's why there's the concept of concurrency. And you want to be mindful of concurrency, meaning how many instances does the Lambda function, Lambda, usually there's a misconception. So Lambda is the service, Lambda function is the function. Usually we say Lambda to talk about the function. But how many instances does your Lambda spin up in parallel to process your all these incoming requests, and whether you so the AWS cloud give you tools to configure it according to your specific needs. And that's where we talk about concurrency, we talk about provision concurrency, and I think we'll touch more about these in the episode.
And I think one of the first things that most people will come into contact with concurrency is the fact that normal AWS accounts have a limit of 1,000. I've seen very small startups who just go, oh, we're just going to load test our system. And we'll hit it with 20,000 requests a second, thinking that Lambda will just infinitely scale. And then they realize, oh, yes, there is a limit to how many concurrent Lambdas you can have in your AWS account. And you can obviously increase this, and I believe at the moment AWS doesn't have a hard limit on how high you can increase it. You just have to put in a request. But yeah, you need to know there is a limit to how many Lambdas you can have running at once in your account. And if you are scaling up really quickly, especially if you're a startup, or there are very high peaks and troughs in your usage, making sure that you're monitoring your maximum concurrency in a day so that you never actually hit the account that's set on your limit. That's something I've seen trip up a couple of startups I've worked with over the past couple of years.
A couple of things I wanted to mention here, since it talks about alerts. So alerts and alarms must be a part of your serverless stack. I make it a point to never deploy a Lambda function if it doesn't have at least 2 alarms attached to it. So the first one is the number of executions. I want to know how, the frequency of the executions when it goes above my pre-calculated, threshold, but also I want to know if it doesn't get executed at all. So if I'm building a Lambda function and I know that this thing is usually hit at least, once every 30 seconds, I will build an alarm there. So if it doesn't run at least once every 30 seconds, I want to know. So I want to receive that. And the other thing is an alarm related to billing. So these are my 2 alarms, because I want to also, when I do my cost calculations and all these things, I know, for example, this workload should cost me, just gonna put a number, $50 a month. $50 is huge, right? It's a lot for Lambda functions. So if it goes over 50 for, 1 hour, 2 hours, I want to receive an alarm. And Lambda recently, they published more CloudWatch metrics. They introduced more CloudWatch metrics that makes this super easy for you to know that. So yeah, not because you can scale infinitely between air quotes, then you should scale infinitely. Right? So we should always be mindful that the biggest thing, I think, when I talk to my customers, my mentees, the biggest thing that keeps coming back is cost, is really cost. And that's why also we see recently, in the recent years, there's a lot of conversation about FinOps. And I mean, now we call it FinOps, but we didn't used to call it FinOps. It's always been there. It just to my, I would say, beginner, because I started this journey in FinOps recently, and to the beginner in this journey, for me, FinOps seems like how to reduce your cost, how to deploy workloads in a more efficient way. You've accumulated all these resources in the cloud for the past 7-8 years because we were in this whole growth economy. So now we're going to stop buying and then we're going to start utilizing more. That's what FinOps sounds to me. But yeah, it's the cost is something that we should always keep in mind. And that's why AWS provides us with things like concurrency, for example.
I think those monitoring points are really important, and talking about later when we get onto like some optimization things, both for performance perspective but also cost perspective. Yeah, I think like knowing when you've got something that has just, especially when there's something that's gone rogue, something that is charging way more than you would ever have expected. I've had that happen to me in the past, and it's not a great conversation having to say, yes, we've got a bill that's 5 times, 10 times what it should have been. So yeah, having those alarms can be absolutely critical. Okay, so cold starts next. So yeah, for those of you who don't know much about cold starts, but everyone seems to think they know everything about cold starts. So as Ilyas was saying, whenever, say you've got a cold Lambda that has never been called before, whenever the first request comes in, that has to spin up a new instance, and that takes a little bit of time to provision that instance on us. It is, even though it's serverless, it is still on a server somewhere. So to provision that, to install the code that you've got, and then to start the execution. The second time that request happens, AWS forwards it to that existing instance, and then it doesn't need to download anything. So the difference between those two are cold starts. And there are quite a few things that affect the cold start time, from the language that you're using to the amount of dependencies, whether you're using layers or even just what is the total code size of your Lambda. So those all can affect your cold starts. And from a user's perspective, it normally just means that Lambda takes longer to process and return a result, which, if you're using something like just API gateway in front of a Lambda, just means a little bit more latency on your request. This also happens whenever you're scaling up and having more concurrency, as we just talked about. So if you've got one Lambda that's getting hit every 10 seconds, and then 2 requests come in at once, that one Lambda can't handle both requests at the same time. So then you have concurrency, and every new instance that's created in concurrency also gets this cold start. So yeah, that's what it is, kind of. And understanding cold starts, I think, is super valuable, because you can both work out how to minimize it, which I think we'll talk about in a couple of other sections later on, but also understanding how that is going to affect your business and whether it is a game changer or a game breaker, or whether it is something that is relatively small. So, for example, if you are running an API and it takes you, say, 1.5 seconds normally for your API to call some other APIs, get some data from a database and return it, in Python or in JavaScript, you might add an extra, 150 or 200 milliseconds to your API request and response time. If you think of that from a user, that's what I think half the time it takes to blink extra in the API request. So in those kind of use cases, having a cold start doesn't really matter, but also cold starts only happen the very first request to an instance. So if you have instances that are repeatedly getting called, I think we did some experimentation a while ago and found that it was something like 0.5% of requests in a normal traffic day caused a cold start. So if 1 in 200 users that click that button have a request that takes like 1/5 of a second longer, is that going to actually affect your business? Is that going to cause a problematic issue for whoever is making the request? And I think for most web apps, it really doesn't make that much difference. The cases where it can be more serious are something like if you're using Java or some of the compiled languages, they have slightly longer slightly longer cold starts. But also, if you're writing an application that is aiming to be returning a response within like 1/4 of a second, if you've got a hard limit that your API needs to, for some reason, return a response in 250 milliseconds, then cold starts can be more of an issue that you need to really consider and think about.
You're absolutely right. I believe that cold starts are usually blown out of proportion. And not all latency is the same. Let's be honest. There are critical latency, right? Sub 20 milliseconds, and as you mentioned, that's maybe the operation room, right? That's life or death situation. That's maybe, I don't know, a missile going, and that's an airplane, that's jets. So that's really critical latency. And then there's loading your e-commerce website. It's not the same, not all latency is the same. And we tend sometimes to want to, yes, we want to squeeze every bit of performance from what we have, but this micro optimizations is not always the path to go. For example, you want to you're running, I would say, an e-commerce website. Truth is, and probably you will gain more from being multi-region and adding cache and preventing your user coming from China, loading your website from US East 1, you'll gain more from that than trying to kill cold starts on a Lambda function, right? There are steps here, and that's also maybe a tangent of a tangent is when people ask me, they want to go, for example, they want to go multi-cloud or cloud hybrid. And I say, well, first, let's go multi-region first before we talk about multi-cloud. There are steps in the evolution of your architecture, of your application, and talking bad about cold starts and saying that you can't use serverless because of cold starts, I think before getting there, there's a ton of other stuff that you need to do before we even get there. So yeah, to your point, usually cold starts are really blown out of proportion and used as a bad thing in Lambda, and as something that's a red flag. But as we will talk also soon, there are ways you could manage your cold starts. There are ways you could reduce their impact. But ultimately, why cold starts happen? So ultimately, it goes back to the old question of reading from disk versus reading from memory. When you run a Lambda function, your Lambda function, the first time it has to fetch the code, and that code usually stored in S3. So your code is packaged, whether you use serverless framework, whether you use SAM, it will package your code and it will put it in S3. So your Lambda function not only has to spin up the container, not only has to start all these APIs that surround the Lambda service, but also it needs to go and fetch the code and inject it into the container. Next time, it just reads it from memory, right? Because it's warm, so it keeps it in the cache. So that's a little bit the difference. But there are ways you can mitigate this risk and bring your latencies from 200, 300 milliseconds to 70, 80, 90 milliseconds, which honestly, and I've I've solved a lot of problems working with a lot of customers. Honestly, it's not a deal breaker at all for majority of web applications. Like trying to get to that 20 milliseconds latency in a highly event-driven architecture, or like it's just not worth it, because at the end of the day, you are making multiple calls to multiple services, which means there is networking involved, which means you will be doing retries, which means you will be doing error handling, which means you need to push stuff in the cache. So it's really, if it's super critical for you to get to that 20 millisecond latency, we are talking SpaceX level. We are talking you're launching boosters and you have a ton of data, and then you need to make decisions in split second, in 20 milliseconds, so the booster doesn't explode. There are odds are you can optimize and get a lot of more return on investments while optimizing other stuff, rather than trying to not to use Lambda function because it can't give you that 20 seconds latency. I just wanted to add that.
I like your analogy about the boosters. And yeah, I used to actually work as an aerospace engineer designing jet engines, so
Wow.
I've seen where those kind of millisecond responses are needed, but yeah,
this is something
very rare.
that doesn't sit right with me. Like, you have people who are designing jet fighters and they are designing boosters and sort of rockets and stuff, and we call those software engineers. And then you have people like us, like me, just build applications that have buttons here and there and to manage the warehouse, and we call ourselves software engineers. And I'm like, no, there's a big difference between these two. The requirements are not the same, the constraints are not the same, the stress level is not the same. So I think we need to invent a different word in the middle there. We need to differentiate these people. Yeah, for me, it's not the same.
Yeah, very, very different kinds of environment. And I can imagine working for Musk is kind of terrifying.
Yeah. Yeah, that's what I keep hearing as well. And I don't know. It's sometimes you need that, between air quotes, benevolent dictator, because you can, and when you want to move forward and you want to go faster, you need someone who takes decisions quick and doesn't, freeze in that whole paralysis analysis kind of thing. So I get that, but there's also a whole other aspect of it, which is working under stress, and which is sometimes going all the way until the end and realizing, no, we didn't, that's not the right solution. So scrap everything and start for. And if you read horror stories coming out of SpaceX and Tesla, they amount to the same. People saying we spent months and millions of dollars building this solution, and then we just realize it's not the right one and scrap everything and start again. So there's pros and cons. I'm not a big fan of Elon, to be honest, but I see what he does. He's able to run his ship very tight.
So let's move on to the next one. So what should and shouldn't you put in environment variables? So yeah, this is one that is probably going to be quite quick. But this for me is around, I've seen quite a lot of personal projects. I've seen people when I've interviewed that when you look at their Lambda function, you look in the environment variables, whether it's in the serverless package itself or in the deployed Lambda, and you start seeing secrets and passwords and credentials. So yeah, I think knowing what you should and shouldn't put into an environment variable is really good. Have you got any kind of way of figuring out should this go in an environment variable? And then if it doesn't, what do you do with it?
Rule of thumb for me is security. As you mentioned, sensitive information, PII, personal identifiable information, secure keys, passwords, all these things. Anytime something is like, that's my rule of thumb. I can almost tolerate anything to be put in an environment variable except anything that is sensitive. And the reason is simple, is because everyone who has access to the configuration of that Lambda will see that type of data. And you don't want that. You want to have security in depth and you want to build your platform following the least privilege principle and all that kind of thing. But if you put secrets in your environment variable, you just, it's like you're building this 5-foot steel door, but then your window is just glass and people can just go from the window, right? So if you put everything sensitive there, everyone can see it, everyone can have access to it, and you don't want that. Now, how to mitigate it? It has been a little bit, what's the word I'm looking for? I would say hard, for the lack of a better word, to do it in the past. But recently, serverless framework and SAM framework, those are pretty much the two frameworks I work with a lot when building serverless Lambda functions. These frameworks, they provide easy, straightforward integration with AWS parameter store and secrets principally the secrets manager. So before, you had to use a plugin in order to fetch the secrets, or you need to find a way to inject the secrets at your Lambda to your Lambda at run. But right now, for example, if you use SAM, in the parameters of your Lambda function, you just write the key of that secret, the key that is stored in your secrets manager, and SAM has a mechanism to fetch that key during runtime for you. And we've done some benchmarking at a company and one of my customers, and we've seen that it doesn't really introduce that much of a latency, super negligible. So using this, if you're still using an old version of SAM or serverless, you won't have access to this. So just make sure that you have the latest version, and that's gonna make it that much easier for you to move forward.
I think one little thing I would add to that is that if you put something into an environment variable, especially if you are deploying it with something like infrastructure as code, so SAM or serverless framework, it's not best practice to go into the Lambda console and add environment variables. But so if you need to update something or change a variable, having it in secrets manager or having it in parameter store is a much neater way of having it. So you can change it in parameter store and you don't need to redeploy your Lambda again. So whereas if you've got it just in your environment variables,
that's a good point.
The only way to have that tracked through infrastructure as code is actually to redeploy that Lambda just to change one environment variable, which kind of adds a bit of latency. And especially if you're having to go through a whole CI/CD with automated tests and branch deployments for just changing a parameter, another reason to go with parameter store or secrets manager. So that is exactly the same approach I tend to take with the clients in my own personal projects. So good to see that we're lining up on that.
Mm-hmm. Yeah, security job zero, as AWS like to preach. Security should always be at the top of everything that you do, for sure.
So the next one is the Lambda memory to CPU relationship. This is around the fact that when you provision a Lambda, you can obviously give it a memory capacity. So anywhere from 128 megabytes all the way up now to 10 gigabytes of memory. But when you change the memory, it doesn't just change the amount of RAM. It also changes basically the CPU capacity that you have. And basically the relationship is it's a kind of small stepped graph. And for the video, I'll try and get a nice graphic of the relationship. But basically between 128 and 1.8 gigabytes, you get a fraction of a CPU thread. So under 1.8 gigs, you're only ever having one thread. But from then on, every 1.8 gigs, you're getting an extra CPU thread. This means that if you're using something like Python or Rust or some other language that can really well optimize for multi-threading, that is great. But if you have no parallelization, or if you're using Node.js and running in a single thread, often going past 1.8 gigs of memory, unless memory is the bottleneck and it's not a compute limitation, then it actually doesn't increase the performance. And I've recently done some benchmarks testing different languages and found that unless you are explicitly adding parallelization to your code so that you can take advantage of those multiple threads, you can go from 1.8 gigs all the way up to 10 gigs, and it won't actually make your Lambda run any faster. So it's just costing you more for the same amount of runtime.
I tend to call it power. I tend to tell my people, look at the memory as power. Just call it Lambda power. The more memory you give it, the more power you give to your Lambda function. It's a linear operation, as you mentioned. And maybe it's also time to mention the Lambda power tuning, the GitHub repo, the code that you could use to pretty much profile your Lambda function and fine tune it and find the right configuration from a memory perspective, CPU perspective. And the way it works, I think it's been a while, I haven't run it, but it deploys maybe we can add link in the description. So it's a repo on GitHub that you clone, then you install in your AWS account, and it installs a state machine on AWS Step Functions. And so you give it as an input your Lambda function, and the way it works is it's going to try your Lambda function using multiple parameters, multiple configuration, and then it's going to give you this nice graph, and it's going to give you an advice on what's the best configuration that you can give to this specific Lambda function. It's a super powerful tool. I think there are two of them. There's the GitHub open source one, and there's also a profiler that AWS started working on a couple of years ago. So either or. One of them actually supports only Python, if I remember correctly. I think that's AWS one, and maybe recently they started supporting JavaScript. So yeah, so that's a powerful tool to help you fine tune your Lambda function and find the right power. Power versus cost, of course.
And I think one of the really interesting things when you run that is often you see that actually increasing the amount of memory because it runs faster actually reduces the amount of cost. Mm-hmm. So it might take you, let's make up some numbers, it might take you a second to run at 128 megabytes, but like timesing that by 4 and going with 512, actually what that does is that reduces the time to run by 6 times. So instead of it taking a second, it's taking 1/6 of a second. So if you do the whole AWS Lambda time times by memory, it actually works out cheaper. So a lot of people go, oh, I'm going to make this as cheap as possible. Let's make it the smallest memory possible. But that isn't always the case, even if you're trying to optimize purely for cost. So that's a fun side note that I've seen quite a few cases like that.
That's a great side note. Not a lot of people are aware of that. You pay per execution, and if you give it more power, you're gonna execute. It's gonna take you less time to execute, so you end up paying less. That's a great, that's something I wish I could write in a poster and just post it in one of, in all companies' halls that use serverless functions. That's for sure.
Awesome. So our next topic is Lambda Layers. So yeah, do you want to introduce it and talk about where it's useful?
Yeah. So Lambda functions, you want your function to be as small as possible. You want it to be straightforward. But sometimes when you are building an application that has multiple Lambda functions, you end up having to repeat code between all these Lambda functions. Let's say you have a bit of code that sends an email or, I don't know, sends a notification or connects to a database, and you don't want every container to have to get that piece of code, parse it, load stuff in the cache, do whatever compilers and interpreters do. So one way of doing that is taking that code and sort of packaging it into a layer that then all your Lambda functions can invoke it's sort of, think of it as an NPM library if you're using JavaScript. So it's like you're building a library that all your functions could use, but it's why it's better actually than in most cases, why it's better than just using like building an NPM library is because of how Lambda optimizes the invocations of these layers. So usually if you're using NPM, it's still JSON file, it's still JavaScript file. They still need to be interpreted. They still need to be compiled or whatever, loaded in the memory. But when you're using a layer, and that's done sequentially. So your Lambda is run, and then we go through but when you're using a layer, that layer is loaded in memory at the same time as your Lambda function is loaded. So like your Lambda function finds it already there. So it's not just waiting. And there are ways also you can take it a little bit further and use extensions, right? And you decide when to invoke this layer. Do I want to invoke it in parallel with my function, after my function has finished execution, before my function has finished execution? So that's a little bit more on the technical side. So that's, I would say, the main use case. You want to leverage layers. So it's a layer of code that lives next to your Lambda function and help you package resources, code, interfaces, DTOs. I've seen people using them for many, many things. And it makes it super easy for you to consume that pieces of code when your Lambda function is run.
I've seen quite a few different approaches to it, from if they're all of your shared libraries all end up in a Lambda layer. I've seen it where it's just any common NPM packages, they get bundled and put into a layer. And then I've seen the opposite, which is one way that I've worked previously, which is actually avoiding Lambda layers, because although there are some really good benefits to Lambda layer, I've also personally found that there are some things that are slightly more challenging. So, for example, if you do update your Lambda code, your common code, and you publish a new Lambda layer, that doesn't necessarily mean that all of the Lambdas that are using that layer are updated to use that layer. So it's a bit complicated. You need to then update the layer and then
use the version.
Yeah, exactly. And then tell all of your Lambdas, hey, there's a new layer version that needs to be updated. And I have seen in the past, and I've been stung by this, where I've updated some library, forgot to update the Lambdas, and then been sat there mashing retry saying, why is this Lambda not doing what I have just updated it to do? So yeah, there are definitely pros and cons and different approaches, and I'm sure there are ways of automating that process of updating all dependent Lambdas. So if you do go that way, there are definitely ways to smooth that over.
And see, in my experience, there are some powerful features in Lambda functions that people underutilize, and one of them is Lambda aliases. And usually the way many folks deploy Lambda, they push their code and replace the existing Lambda with the new one. It's just slap the new one over the previous one. And even though these folks might be well versed in everything that is blue-green deployments and canary deployments, when it comes to Lambda function, we just replace the Lambda function. But there are ways, for example, if you use aliases, what happens is that, or SAM allows you to use canary deployment and shift traffic gradually between aliases. So let's say you have a running Lambda function, and so you deploy new ones. And so what it does, it creates an alias, like a load balancer, and then it starts shifting your 10%, 20%. You can configure it. I think that's where we're going to be talking more about this in versioning, right? All right, I'm not going to jump.
Yeah, definitely.
Okay, let's talk about this more in versioning. Yeah, a great use case for layers is, as you said, updating dependencies. because you don't have to update your Lambda functions, but this means that you need to configure your Lambda function in the right way that it can take advantage of these dependencies. And sometimes you can use versions, you can hardcore the version of the layer. Sometimes you can use, I think you can use latest also to just always get the latest, because if you don't specify a version, it will always get the latest version of your layer. So there are a couple of ways, and as long as you're mindful about these, and as long as your I would say code does not get heavily impacted, negatively impacted if the dependencies change, then I think there's some benefits to get from that.
Yeah, definitely. So kind of on a similar note to what you're talking about there, and like optimizing your deployment to minimize the Lambda. The next thing is, deployment package optimization. So yeah, we've already kind of half covered the first step of this, which is if you've got any common code, then you can bundle that into a layer and have that separated from your actual individual Lambda code. So have you got any, should we talk about why it's, we've kind of already talked about why it's beneficial, but do you want to just quickly go over that again?
Yeah, sure. The lower your code, the smaller your code is, the lower time it will take Lambda to go through that initialization phase. Because remember, the Lambda is creating a container, then it's fetching your code and injecting it, and then it's ready to. Usually it happens in terms of milliseconds, but the smaller that code, then the faster it will go. So you have to, like, in my perspective, in my opinion, spend all time that you can afford reducing the size of your packages, for sure.
So yeah, I think one of the kind of things that I suppose I did when I very first started working with Lambda was I would just install some node packages to my Lambda deployment and hit deploy, and you're deploying sometimes like a Lambda function that has a very simple bit of business logic. So maybe calling some Dynamo APIs, maybe making a request, working out some times and dates, and then sending a response to the customer. And I've had it where at the very start when I was learning Lambda, I would include like Moment and all these other date libraries, and I'd use libraries for making like Axios requests to other projects. And when you actually get around to doing the deployment, sometimes you're getting like 20, 30, 40 megabyte large Lambda deployments because you're including the whole of that Lambda NPM package inside your deployment, which you could just be using literally like one line or one function from that package. But if you're not using a bundler of any kind, then you end up actually just including the whole of that package, which means you're loading loads of extra non-used code into those containers.
Absolutely, Sam. And it's actually, you raised a good point. You said when I was starting working on serverless, because usually as juniors, when we move to serverless, we tend to bring with us the non-serverless way of doing things, like containers and like VMs. And what you've mentioned would have been completely, perfectly normal in a VM world, because what happens is that npm install or npm update or whatever, it's done once, and then all these packages are kept in memory, and then the event loop is running and just intercepting, in the case of JavaScript, intercepting requests, but it doesn't have to reload everything. Everything is just loaded in memory. But in a Lambda function where your lifecycle is super short, you don't want to every request load all these dependencies. And we all know how NPM dependencies can get super long and super heavy. So there are a couple of things we can do here, right? We can, as you mentioned, we want to remove any unnecessary files. We want to remove any unnecessary libraries. I sometimes tell my people, I would prefer, for example, to use a native way of making a simple get call, if I just have to make a get call or use a request package on NPM rather than using Axios, because I know that Axios is a little bit heavy. It has its advantages, of course. It's a little bit heavy on the resources wise. Something else also, when we start reviewing and we start, I see a lot of mentality, like philosophies behind building, I would say software engineering philosophies brought into serverless, and I don't usually agree with. For example, before serverless, we are used to build interfaces, or repositories. So I build my code, and if my code has to access a DynamoDB, a database, let's say MySQL, then I build an interface that sits between my business logic and between the database. Because the thinking is, what if tomorrow I decide to use PostgreSQL? What if tomorrow I decide to use MongoDB? So I don't want to change my code. I just will change the interface, right? And makes sense in a non-serverless world. But in a serverless world, I tell my people, build your Lambda function to go directly interface with the DynamoDB table, to go directly interface with the MySQL. Because if tomorrow, and that's a big if, we have to change the database, we'll just create a new Lambda function that now goes and write that new and read from that new database, and then we'll handle that fanning out and that routing, we'll handle it before the Lambda function, right? So people usually think about one Lambda function as a whole. I can put a whole application in it. But no, you actually want to build your application using as many Lambda functions as required, and you want your Lambda functions to be really as small as possible. And this, I've seen it in code that I review pretty much every day. People tend to use DTOs, and they tend to use interfaces, repositories. They tend to build services within the Lambda function. And there's nothing wrong with these approaches, but just keep in mind that these solutions were built for a different world. They were built for a different mechanism. They were built for a world where we needed an ORM because Java was super heavy, and then we needed to map variables in the code with fields in the database. So that's why we used ORMs. And yes, there's hydration and other, but in a world where usually, you are reading from a Dynamo, you are writing, you don't need this ORM. So I see people using JavaScript ORMs in Lambda functions. I'm like, trust me, you really don't need that. Don't need to use that. So you need to start thinking in a serverless way if you want to take advantage from you need to squeeze every bit of performance from serverless. Otherwise, you're just exchanging one set of problems with another. You're just exchanging a platform with another, and you're just doing a lift and shift to the Lambda function, and you don't want to do that. It's just going to cost you more in terms of money, but of course in terms of time to go to market, in terms of debugging time takes to debug all these kind of things. So I see that a lot of times organizations want to go serverless, but they don't take the time to go through the serverless mind shift, the serverless way of thinking, and adopt it. Now, to go back, I know this was another tangent, to go back to how to reduce the time, there is definitely, you want to remove unnecessary files, you want to remove unnecessary libraries. We talked about using Lambda Layers. You definitely want to use Lambda Layers to manage the dependencies and all this common code. We also talk a lot about tree shaking, and I found myself leveraging some packages in JavaScript from NPM. I forget the name of the package that helps me do some tree shaking and find those packages that I probably do not need, and just get rid of them and deploy in the code as slim as possible. I see sometimes also people do a ton of console log in the Lambda function. I don't know, it makes sense, right? But again, that would be better suited for a non-serverless. In serverless, you're paying by millisecond. We are here trying to squeeze every bit of performance of our function. So there are ways, of course, you can monitor and you can debug, and monitoring and debugging is super important. But don't just throw console log every couple of lines there and hope for the best. Yeah, that's I'm gonna stop my rant.
No, it sounds good. And I think I'm going to add one more thing onto the end of this discussion, which I'll save as a little surprise for you at the end.
Okay.
But yes, so the next thing is kind of provisioned and reserved capacity. Now, we've obviously talked a little bit about this right at the very start, but specifically I wanted to discuss actually kind of what are provisioned and reserved capacity, and then when to use which one of them in which cases, and kind of the approach you can use to ensure that you're optimizing for either performance or optimizing for resiliency with reserved capacity.
Yeah.
So
Go ahead. Sorry, did I cut you? Do you wanna?
I'll try do a quick introduction to these. So provisioned capacity is just where you say, I want there to be, say, 5 concurrent versions of this Lambda instance alive all of the time. This means that if you get a request, there is already a warm Lambda that is just waiting. So that means that in those cases where, as we said before, there is a cold start, when you have to create a new instance, because there are already provisioned instances, then you don't have that cold start. So if you are the Elon Musks of the world, and okay, we have an API and we need to get the absolute fastest response possible because it's going to break our self-driving cars, then actually you go, okay, we know that we're going to get a maximum of 100 concurrent requests. So we're going to provision 120 concurrency so that we can consistently handle all of that with absolutely zero cold start. And the flip side of that is kind of reserved capacity. And this works the other way around. Whereas if your account has a limit of 1,000 concurrent lambdas, then reserved means this number of lambdas are always available, but they're not necessarily on for this lambda. So if you say that you've got 5 reserved concurrency for lambda A, and then lambda B, something happens and you're getting absolutely hammered but with thousands of requests, then that will fill up all 995 of your other concurrency, but it will not be able to overrun those 5 reserved capacity. This means that there is always going to be at least some level of availability for every one of your lambdas. Now, these two do have other limitations. So scaling beyond your reserved capacity is possible. So if you have 8 requests to that thing that has a reserved of 5, then that will scale beyond that. So you're not limiting your capacity with reserved capacity.
Absolutely. And the limits that you mentioned, Sam, are, I want people to be aware that these limits are per account, per region. So there are limits that are completely per region, but for the Lambda reserved concurrency is per account, per region, meaning that if you use 2 accounts, then now you have up to 2,000. If you use 3 accounts, and we're talking about serverless here, if your code runs in a certain way in account A, you can be sure it will run the same exact way in account B. So I tell people, take advantage of that. Why be limited to 1,000 execution in one account if you can deploy your code on 5 accounts, and now you have 5,000 execution. And another thing I like also about this game in the system model is you get also 1 million free execution per account. 1 million free Lambda execution per account. So if you deploy this on 5 accounts, you'll now have 5 million free executions per account. Why limit yourself? So just game the system, use as many accounts as you can, deploy your code across these different accounts and take advantage of, like, increase your limits, take advantage of free tier, take advantage of all these free executions that you get, by the way, not only in Lambda function, you get them on SQS, you get them on SNS, you get them on other serverless functions as well.
Yeah, definitely. I've seen the multi-account thing being used in quite a few different ways. And this probably is a discussion for another video, but yeah, I've seen it where it's a microservice. Each microservice gets their own AWS account. I've seen it where each team gets their own AWS account. There are loads of different ways of structuring your AWS organization and kind of the architecture within it. But yeah, that's definitely something for another video. But yeah, definitely going to be keen to get Ilias back on a call to talk through so many more things around serverless and AWS. So yeah, should we move on to the next one, or have you got anything else you want to raise about provisioned and reserved capacity?
You've said it all. Yeah, no, you've actually touched it all. There's the allocation aspects, there's the pre-provision aspect, and you know what? I'm just going to be repeating what you said. Let's move on.
Okay, perfect. So, getting down to the last 4, and then our special extra one. So, global variables. So this is something that's like, as from a content side of things, one of my first articles I ever wrote was about Lambda global variables. And for anyone that doesn't know, when you write a Lambda function, you've got your main handler. And at least from the JavaScript perspective, if you then declare a variable outside of that, then whenever your Lambda function is triggered, if you write something into that variable outside of your main handler, and then the second request comes in, that will be able to read that, and that is persisted between requests. Whereas any variable that is defined inside the handler is cleared, is forgotten because of scope, and each request will have a new variable inside. So this can be used for things like a very budget cache mechanism, where if there is a read to a database that you need to do for absolutely every request, but it changes maybe once every month or once every 6 months, then what you can do is you can just go on the first request, get it from the database, and store it as a global variable. On the second request, you can check if that global variable is fulfilled. If it is, just use that value. So these values are then persisted until the Lambda instance goes cold. And then the next time that a new instance is created, it needs to then first fill up that global variable. And yeah, this can save on database writes or requests with kind of known results, or at least results that don't change very commonly.
Yeah, for sure. I tend to divide the code in a Lambda function in 2 sections. Code that is outside of the handler, and then code that is inside of the handler. That's it. Code that is outside of the handler, it's executed only once during cold start. Code that is inside of the handler is executed on every invocation. So as you mentioned, a way to handle a database connection pool is to initialize that connection outside. So it's only executed once, and then it's used for every other invocations. AWS was super concerned and super aware about this thing, that they created a new feature in RDS proxy, that allows you to handle this database connection pools, but it's still a great use case to always initialize your connection to database outside of the handler. And I see people use it for connecting to cache instances for databases, multiple, also for sending multiple alarms and multiple metrics counters. So yeah, outside, inside. Outside will run only once at cold start. Inside will run on every invocation.
Yeah, I really like that way of thinking about it, and yeah, definitely simplifies the approach to how you write your and run your code. So yeah, that kind of very nicely brings us on to the next one, which is the reuse of database connections. So yeah, you've already talked about this. So do you want to carry on? Is there anything else you want to say about the database connection topic?
Well, you want to use a connection pool. That's for sure. This how you build it. It's gonna depend on the technology, the runtime, the language that you are using, and also which database you are using. Some databases you don't even need them because you just have an API interface that you need to call. But usually, yeah, you want to initialize your pool outside of the handler, so every invocation takes advantage of that connection that it's already been created, and you don't have to always create a new. And also you can you can solve this problem from multiple layers, I would say, because you can also configure your database to always have a connection open, but then you can configure it to close the connection after every request. And so you need to create a new connection on every request. But usually in a Lambda function, in a typical world, you want to declare you want to create your connection pool outside of the handler, and then you just want to reuse it within the handler. And I think this way it's gonna operate the same regardless of at least the same in all the runtimes that are officially supported by AWS. And I've read an article recently about how AWS doesn't update the runtimes that often as much as they could. It's still don't support Python 3.11, for example. 3.10 is maybe 3-4 years old now. So yeah, that's I hope AWS people would get up and would get up to speed on updating their official runtimes.
Yeah. Interestingly, I had a call with AWS just before Node 18 came out, and they were talking about that process. And now they are very keen on, as soon as there is a new beta release of a runtime, especially with Python and JavaScript, they are wanting to basically be ahead of the curve, so that before Node 20 ever actually goes into general access, they want to be able to have the ability to run Lambdas using the beta access. So hopefully in the future they know, and they are very actively looking into doing this to make sure that as soon as the newest version of Lambda of Node is available, or Python. So it was a long wait for, I think it was Node 16 was out for a very, very long time before Lambda supported it. I still remember the days of running on I think it was Node 6 and being amazed when async await came out inside Lambda.
Yeah.
It blew my mind being able to do that. So yeah, it's good to know that AWS are actively trying to keep that cycle going and speed up the time to get new runtimes out. Then it came to working out how much difference it would make, and it's if you do 500 million requests a month, it makes $20 of difference.
There you go.
And it was okay, so
there you go.
It was the same when millisecond billing came out, and the team I was on, we spent a whole day trying to go through all the Lambdas and try and figure out which ones we could optimize to save, purely based on cost, not on user experience. And we're we've managed to optimize these things and worked out that we'd saved $150 a month, which sounds amazing. And then you realize that was six senior engineers spending a full day.
There you go.
If you worked out the return on investment, it was 13 years.
There you go. That's one of the fights, man. I have that's one of my daily fights. Let's meet and 6 people, and then for 1 hour and decide what to do next. I'm you know what? If you just take 30 minutes and build a POC and deploy it and get feedback from it, it's gonna be way more cost efficient than meeting and talking, and you'll get real feedback. And because when it comes like, what is $20 a month for a company, like versus the time it takes to build and deploy, and that not taking in consideration changing your CI/CD pipeline to deploy, and then the bugs that you're gonna have, and then the rollbacks, and then all the back and forth and emails, and there's a lot of efficiency that can come up from just becoming a little bit more agile, deploy stuff, learn from it, rather than. Anyways, that's another rant. That's another one of my fights.
Join the club. Yeah.
Yep.
So, trying to get us back on topic a little bit, let's talk about versioning. So, you talked earlier about having and making the most of Lambda versioning. So, that is where, like, every time you deploy a Lambda, it gets a version number. So, it might be version 36, 37, 38. And what you can do is you can then add aliases to these. So, do you want to talk about that and how you've used that to basically, as you said before, the common deployment mechanism is I'm going to deploy it, and API gateway is just going to point at the latest, which means that my brand new change is going to be hit by every bit of traffic. But obviously there are more advanced and more intelligent ways of doing this. So do you want to talk about that and how users could implement it?
Sure, I can start it off. Every deployment creates a new version, and you want to be mindful of these versions. AWS does the heavy lifting bit of it for you. You don't have to increment anything. You just deploy a new bit of code. AWS will create like a fork. It'll create a new version and will automatically route the traffic from whoever invokes that Lambda function to the latest version, unless you specify the version you want to invoke. So let's say you made 5 deployments, but you still want to invoke version number 1, the first version, because whatever reason, because you noticed there's a bug, because you wanted to roll back, because you did a change that you didn't want to do. So there's a way you can play with the version, and it's like routes. So the Lambda service gives you sort of a way to route the traffic, and not only across Lambda functions, but across versions of the same Lambda function, and every deployment is a new version. Now, you can take this a little bit further, and in order to make your function more, I would say, fault tolerant and more resilient, by building a whole CD or a whole CD pipeline around it. And the way you can do that is when you deploy a new version, you can create an alias, and that's shortcuts. And then you can have that alias point to the new version, to your latest version, and you can configure traffic. And the way you can do it is either you do it manually by using code, it's called build, and then it's called deploy, by writing code in your infrastructure as code, using code deploy to start shifting traffic, 10% of traffic every 5 minutes, 10 minutes. Or if you use AWS SAM, it does it for you automatically. You really just add 2 lines of code. You add, if I remember right, publish versions true or something like that. Oh, use aliases true, publish, whatever. And the other one is you configure the type of traffic that you want, the strategy that you want to use to shift traffic for your either canary or linear, or you can do it step by step. After that, you are required to create alarms, 2 alarms and 2 CloudWatch metrics. And so it's based on these alarms that code deploy is going to do. So the way it's going to work is your Lambda function is deployed and your alias is created. Code deploy is going to shift 5% of traffic and then wait for, however, maybe you said 5% every 10 minutes. And it's going to wait and it's going to keep checking those alarms that you published with your Lambda function. And if one of these alarms, raises a red flag, there's an error. It's going to automatically roll back to your previous version. If there's not, it's going to shift another 5%, another 10%. It's going to keep doing it until you get to 100% of traffic. All you had to do, couple of lines, create. There are a ton of, I would say, templates out there that people can use on GitHub or whatever. So usually it's really copy paste and then change a couple of parameters here and there. And you've just made your Lambda function 10 times more resilient just by leveraging these features that Lambda provides, along with other features that code deploy, that the whole code stack, code build, code pipeline, code deploy that AWS provides. I wish there was a way to connect this with GitHub Actions. That probably someone somewhere is working on something like that, but I hope that AWS would support it, like work with Sam team to support this natively, officially. You know how AWS always likes to say that we don't compete, GitHub is our friend. Sam doesn't compete with serverless. We're all here to solve people's problems. Well, you know what? This is something that we would love to have. So if AWS can add this canary deployments using GitHub Actions, that would be awesome.
Yeah, so that's something I'd not seen done in such an automatic way before Sam. I'd seen people do something similar, like either using step functions or manually doing it. And that it definitely works, but obviously having that automatic every 10 minutes, add another 10% of traffic, that is really a really nice way to gradually basically like test your new code in production. And then also, as you say, those alarms, being able to automatically roll back if something doesn't work in the way you expect it to is really nice. And I'm wondering, this is something I've not actually looked into, if there's an equivalent package or plugin for the serverless framework, because having that automated process is something I could imagine building in serverless framework as a plugin, but I'd be really cool to actually implement that and see how they work as like an equivalence.
I'm sure someone in the comments will correct us, will say, hey, yes, it exists 4 years ago, here's the link. No, but seriously, it makes the whole pipeline tremendously resilient, honestly. And also it uses code deploy, and the visuals are pretty good. Like it builds a dashboard for you in code deploy, and you can see the blue line moving 10%, 20%, 30%. And at any point, you could just click on a button, stop and roll back if you noticed something by yourself. It just takes it to a whole different level. It takes Lambda from being I'm just gonna write a bunch of lines of code and send it there, to actually to the level of building resilient and fault tolerant applications and highly available applications on the web without much effort, to be honest.
Yeah, it's amazing how much Lambda has come forward in the last 5-6 years from that. Just it's somewhere that runs my code to it's actually a well thought out, hardened, operationally secure mechanism. So the last one we had on our list was x86 versus ARM or ARM. Have you had much experimentation with this? Have you?
Honestly, I haven't. Haven't. My knowledge about this is highly theoretical. The cost gains by using an ARM, and the level of execution that you get from it, but it's really highly theoretical.
Yeah. So for people that don't know about this, by default, most Lambda functions when you create them run on x86, which is just a normal Intel or AMD kind of motherboard and CPU, and that's kind of the default execution time. With ARM, AWS have developed their own, I believe it's their own socket and their own chip.
Based on Graviton.
Because it's their own chip, and it's using the ARM framework, which is, by the way, I'm not a hardware engineer, so if I use the wrong terminology, I apologize. But because AWS have developed it themselves, and they manufacture it themselves, they can get it for a lot cheaper, and they have optimized it more for the use of Lambda and the architectural requirements to make it basically optimized for that specific use case.
Yeah.
It does mean that there are some variations in how things run, but from AWS's own marketing output, it's said one thing is it is cheaper to run per second than a x86 Lambda.
They mentioned 20% cheaper.
Okay.
Yeah.
Yeah. And they do say that it's under certain workloads that they have tested, it is actually also faster than x86. I've done some testing and found some mixed results. So I have found some where, like, these were all very, like, non-real world use cases, but just like, here are just some Lambdas. We're going to try and run them in both configurations. Some were quicker, some were slower, and some of them were slower to the point where they were actually more expensive, even with the cost savings that you're getting, than running it in x86. So I don't think there is a definitive move to ARM and you'll save between 10 and 20%. I don't think that's something you can just outright say at the moment. But I think over time we'll hopefully find that there are either use cases or workloads that are very well suited to it and workloads that aren't.
I've worked with multiple customers to use Graviton for Kubernetes clusters, and we've seen significant cost optimization there. But it's interesting that it doesn't translate to the Lambda function, to Lambda use cases. Maybe it's the way, Lambda is handled under the hood. But yeah, it's definitely not a plug and play. But this whole move to companies building their own architectures, their own chips architectures, I think it's super, super interesting. And I'm going to go on a limb here and I'm going to say that the future, I mean, we already know that Apple built its own M1 chips or M2, and now they're thinking about M3, and those are built on ARM architecture, right? And I'm thinking that companies will, imagine a database, imagine MySQL, rather than being a software, imagine it being a hardware chip. Imagine you purchase a hardware, an instance, and all the processes of MySQL are imprinted in the chip itself. Imagine the speed you will get in such, because there's no translation, there's no software needs to be compiled, there's no memory leaks, stack overflows, whatever. You're bypassing the whole software and you're going directly to the hardware. Like, I'm gonna go on a limb and say that the future is gonna be this. You're gonna see these cloud providers building more and more services and translating them into hardware services. And we see already AWS built their own chip for inference, for machine learning. They call it Inferentia X1 or something like that. So it's a chip that is designed more for machine learning workloads. Part of the ways how Apple, and I keep looking at my MacBook, how Apple is improving in their M1 and M2 chips, part of is they built the encoding and decoding mechanisms in the chips themselves. Like if you, for example, you encode your video on Final Cut Pro or whatever, they don't go through a software. Maybe there's some kind of software, but the whole encoding mechanism is in the hardware. So I'm thinking, what's gonna stop these big giant companies from having a Redis on a chip and having a DynamoDB on a chip? That would be amazing. That would be a great world to live in. It's gonna be, well, yeah, we're gonna see the rise again of hardware engineering again. And, we shouldn't call these people software engineers. Those are a whole different breed of engineers. But yeah, it's super important. It's super interesting to me to see this move to ARM versus Intel. And Intel has been monopolizing this chip manufacturing for like decades. And part of why it's expensive is because all the companies need to pay a license and whatever. And then you have one company that does the R&D. But now AWS is big enough, Google is big enough, Apple is big enough, all these companies are big enough to build their own chips and keep pushing for better energy utilization, for better speed, better performance, which at the end of the day translates to lower cost for end customers. So I think it's great to experience with the ARM for Lambda function, but you just need to make sure that because not all libraries, it's a different architecture, and you know how these chips, they have all this logics built, these logic gates built into them, and they need to communicate with memory. You just need to make sure that the packages that you're using and the code that you're building is actually optimized for ARM architecture. Otherwise, you are not realizing the promise that you hope to get.
So I think from my side of things, I'd say try it out. If you've got some lambdas, try running them and do some performance testing, seeing if x86 versus ARM. In the same way, you should do some performance testing to see which memory capacity gives you the best results. See if which instance type works best for you, and go with whichever one meets your workload best. Because you're never gonna, at the moment, I don't think we can predict or outright say that one's better than the other. So the last little secret question I just thought of earlier in the video was, you said a lot about when you're optimizing code for deployment packages, not having that interface. One thing that working with AWS you'll hear a lot is the fear of vendor lock-in, and the fact that if you write your code for Lambda functions and then something happens at AWS, whether they make it way more expensive or start imposing other restrictions, and you want to move to another platform, then first, you're now, at the moment, you'd be stuck inside Lambda and it would have to rewrite it. One kind of defensive mechanism that I've heard a lot of people talk about is using those kind of interfaces where you separate your business logic into one set of code that then has just like a database interface or an email interface. What is your opinion on that kind of mechanism and of like vendor lock-in in general for like Lambda functions?
Yeah, my opinion on this is highly unpopular. People don't usually agree, but I'm gonna be honest here. I think that everyone is vendor locked, whether you want it or not. When you choose to write your code in JavaScript, you are vendor locked in JavaScript. When you choose to write in Python, you're limited yourself. There will always be a level of vendor lock-in. That's the first thing. The second thing is we like to think that, what if in the future, after building this business and having like building a reputation and pushing my product to customers and being on the market for 5 years, what if I decide to replace my MySQL by PostgreSQL? Reality, that's never happened. Have you ever seen it? I've never seen it. If there's a use case like this, then trust me, we will be re-architecturing our application. We will be modernizing our application. We will not just choose to replace one database engine with another one. Like, we like to think these questions are interesting from a philosophical perspective, but when you hit the ground, when we're talking about business realities and we talk about challenges, you rarely see companies saying, hey, I decided to change my... So it becomes a lot of investment. We spend a lot of time building those interfaces for a benefit that might or might not come in the future. And we just keep adding all these levels. Like, for software engineers, it's easy. You want to solve a problem? Add an interface. separate, use an event bus, use a facade. Like, this is how we like to solve our problems. But too many interfaces becomes an anti-pattern at the same time. And we spend a lot of time, like I've been reviewing code that I had to go 10 levels down just to understand what the function does. Because this function has this thing injected, and this thing injected preloads this thing, and then there's, I don't know, dependency injection here, and there's a facade here, and there's an interface here, and there's a ditch here. I'm like, at the end of the day, I understand that you're trying to play by the book, but this is not, you're not trying to pass an exam at university, right? This is about delivering a feature, and you should look at it, your constraints and your requirements should be different. Of course, we want code that is maintainable. Of course, we want code that is easy to run, that is debuggable. But I don't want, when I hire someone new, a newcomer, I don't want to take them 3 months to just understand what the hell is this spaghetti. I don't want it to take me, to have to change 10 files just if I wanted to change one name of a variable, or because I need, there's tests and there's stuff like that. So again, I think we need to accept that there will always be a level of vendor lock-in. And it's the same way as if I like, I don't know, Nike, and I'll buy a Nike shoes. No one wakes up in the morning and say, hey, what if tomorrow I decide I don't like Nike anymore and I want to use Adidas? Why do we think the same thing about software? And I know my opinion. I know some people in the comments will not be happy. I know people will tell me I'm missing something here and there. I'm trying to be as realistic as I can. I've seen pretty much both ends of the spectrum, and it is a continuum. It's not extreme. There is a way in the middle where we can say, today, with the realities, with my business challenges, with my requirements, Lambda is the right solution for me, Lambda function. So I'm going to write my code in a way that it's easily packageable, and I can move, if in 10 years, I will move to a different one. But that's an if, and that should not be your main priority, and that should be given like 1% of the load, of the mental load and mental gymnastics that, and thinking about it. It should not be your primary goal when building something. And, on the other end, also, there are people who say the same thing about containers, who will say, like a conversation I find myself a lot into is Google Anthos. And people say like, hey, I don't want to use EKS or whatever. I just want to use Google Anthos because it allows me, it's vendor agnostic. And I keep telling them, Google Anthos is vendor lock-in. You are using a product by GCP, developed by Google, regardless of the promises. It is vendor lock-in. So there are discussions that, I'm happy to have from a philosophical perspective, and we'll have on while having a drink, and we'll talk how vendor lock-in is bad. But when we talk about realistic workloads and let's solve problems for capitalists, organization that trying to have revenue and make money and iterate faster and bring value to the customers faster, I think there are other priorities that we need to focus on rather than spending time and money investing in building all these interfaces. So maybe in the future, or maybe not, maybe there's a chance that we can move to a different vendor. I know not everyone is. I'm interested to actually know your perspective about this.
Yeah, so I probably fall into a very similar camp to you, where I think it's massively overhyped, the vendor lock-in. And I think that kind of comes down to like a misunderstanding of like what risk is. And at least for me, like I came from aerospace engineering, we were designing jet engines, and risk
completely
risk had
different.
Completely different, but too much paperwork for me. So risk in that case was always like, so it's two components. There's what is the damage if this goes wrong, and then what is the probability of that going wrong. So for example, if you're designing one of the blades at the front of the jet engine, if that goes wrong, then that's going to go into the rest of the jet engine and destroy everything behind it. So the damage is horrendous. Probability of that happening, they make sure they design that so well so that that is absolutely perfectly optimized so that the chance of that happening is really small. If you look at something at the back of the engine, so for example, the nozzle at the back of the engine, that if that breaks, if that falls off, it's just going to fly out into the sky. That's going to land somewhere on the ground. It hasn't got that much impact. Therefore, actually, you don't need to design it to quite the same level of obsessive levels of protection of insurance, because so it could be that that happens maybe 1 in 100,000 hours of flying. That happens. It's like, it kind of happens. And with software, it's like, what is the chance that AWS does double their price? What is the chance that AWS shuts down your account? What is the chance that AWS goes, oh, actually, we don't like Lambda anymore, we're going to get rid of it?
Very slim.
The chances of those things happening are astronomically tiny. Like, I've seen AWS decrease prices on hundreds of services. I've never seen them increase a price anywhere, although someone's probably going to find one obscure service where they did. So it's timesing. How damaging would this be? So if you are completely Lambda, completely custom, how much would it take to migrate your whole database and your whole software from Lambda to something else? Times that by how likely is it to happen? So because it's so unlikely, the overall risk is absolutely tiny. Whereas if you go, okay, we're going to have interfaces on everything, we're going to have abstraction over abstraction over abstraction, you are reducing the damage that migration cost would have, but you're then also saying, okay, what is the chances that the product is going to be 50% longer to develop because you're adding all this complexity? So you're guaranteed to have more complexity, times that by increasing your cost of development by 50%. If you compare those two numbers, actually, you probably have a tiny, tiny actual risk of vendor lock-in damage, but the risk for developing slower, having a competitor turn up who goes faster than you, like spending all of your lovely VC cash on developers to build this perfectly abstracted solution and then not getting to revenue fast enough and your company going bust before the possibility of migrating between AWS to GCP is like even a concept. So like I always try and say, work out how likely it is to happen and then work out what the damage might be, and then compare that to what is the damage if you do just go for it and go, we're going to be completely serverless.
But that's hard, right? That's hard. That requires people sitting in and doing a boring task, which is calculating. But people don't want to do that. They just say, no, vendor lock-in is bad. Let's just do something else. And let's throw this problem over engineer. Like, let's let engineers build. I don't want to do my job. I 100% agree with you. I like this analogy of risk that you brought in. I'm going to start using it. I'm going to steal that. I'm going to start using it in my future conversations. It's at the end of the day, it's always investment versus return on investment. And, there are way more highly, I would say, or even profitable problems to tackle from a return on investment perspective, to tackle way before we start worrying about vendor lock-in, as you mentioned. I'm glad we are actually aligned. So two of us have unpopular opinions now. That's cool.
Yeah, I find the unpopular opinions often end up being there's a surprising number of unpopular
I
opinions that
see.
eventually become the de facto opinion after a couple of years. So we'll
Well,
see.
the reasonable man versus the non-reasonable man, right? The reasonable man accepts the world the way it is. I'm paraphrasing, but basically the non-reasonable one is the one who tries to make the world think like him. And by doing so, challenge status quo and stuff like that. And once in a time, once in 100 or 1,000, whatever, it ends up bringing something good to humanity. So it's not so unreasonable after all.
Well, this has been an absolutely amazing chat, and I've really enjoyed myself. Yeah, it's been great getting to chat with you and hear your opinions on quite a lot of these topics. And hopefully, for everyone that's watching, like, you'll now have a deeper understanding of some of these more advanced topics, and some things. Hopefully, you'll go, "Oh, I didn't know that," and that's a really good place to kind of start and go, "Okay, these are the things I want to learn more about," or these are the things where I can make improvements to myself as a developer, or even as a company, like, how do we approach our use of Lambda and how do we make it better? Yeah, Ilias, I'm absolutely certain that we're going to have another catch up like this again.
My pleasure.
Because I've
Yeah,
thoroughly
it would be a
enjoyed
pleasure.
myself.
Oh yeah, me too, man.
Yeah.
I've enjoyed the conversation. I mean, we set up to talk for like, I don't know, 45 minutes, 1 hour, and we're way past that. Yeah, I love this chat. Let's do more of these. I would be delighted to. Thank you for the opportunity, and yeah, man, and see you soon.